Hi, Chris Mc Loone here with Fire Apparatus and Emergency Equipment. Welcome to this episode of our podcast. This month, or this episode, is going to be another water delivery episode. And as usual, I have my two water delivery gurus here, Bill Adkins and Andy Soccodato. We'll get right into it. Today, what we're going to talk about is testing your hand lines for the appropriate flows, why it's important, some different ways to do it, why we have to do it nowadays. We can't just rely anymore on the hose manufacturers giving us, the friction loss so that we can compute the proper pump discharge pressure. Many of them, if not all, don't publish those numbers anymore. So it's really incumbent upon the fire company to figure all this out on its own. And it gets even a little trickier if you are running, say you're running cross lays or pre-connects off the rear, and they're different hose manufacturers. So you have to figure it out for each one. So Andy, Bill, thank you very much for joining me again. Bill, I'm going to start with you today to get us rolling here. Could you just explain why it's important for fire departments to properly test hand lines for appropriate flows by itself, not relying on another place to do it for them?
Sure, Chris. Thank you for having us, and glad we're to do this episode yet again. Is it important to test hand lines off your apparatus? And that is absolutely. Each apparatus pump configuration is a little bit different, maybe because of where the pump is mounted on that truck. It may have a few bends that another truck would not have. So it's going to create some type of friction loss. And when we buy hose, it comes with a chart telling us how much flow it should be at a certain pressure. And we have to test those based off of our nozzles that we are using, and we use a flow meter to make sure that we bring that pressure to the pump up to get the flow that we are wanting to achieve. What does that nozzle say it should achieve? 7/8 tip on a smoothbore nozzle is 161 gallons a minute. So we would, you're going to bring that pump pressure up until you're achieving that 161 gallons a minute, roughly. And then we can lock that in so that we know when we flow on the fire ground, we need to bring that pump up to that certain pressure. And then we know we're flowing and what we're expecting to get out of that nozzle.
Andy, how about you? Why is it important that the department do that itself?
Yeah, like Bill said, it is critically important to do this because there's a lot of variables that go into it, and using the standard hose coefficients for attack lines out of a pump textbook typically could, those older hose coefficients aren't accurate for hose construction today. There's a lot of different techniques that are being used today, and in fact, a lot of hose manufacturers, depending on the brand of hose and the model of hose, the hose isn't truly 1 3/4 in internal diameter. It actually might be a little bit larger and be closer to 2 inch, depending on what you're purchasing. So if I use a hose coefficient of 15.5, like we have been taught in basic pump classes, on hose that is closer to 2 inches in internal diameter, I'm going to have pump discharge pressures that are stupidly high, and I'm ultimately going to hurt the people at the end of that nozzle. And Bill hit the nail right on the head when he talked about plumbing loss within the truck. Traditional theoretical hydraulic calculations, typically we're only figuring loss from the discharge at the pumper to the nozzle. And there's a lot of stuff that goes on inside the pump that, depending on the flows and the plumbing configuration, I could have a significant amount of loss just within the pump itself that is going to require me to set my pump discharge pressure to maybe a higher number at the pump panel to get the flow that I want at the nozzle. And that's all dependent on where the pickup tube for the gauge is in relation to those bends and plumbing in the truck. So when I do a flow test on my particular apparatus, I am dialing those pump pressures in to what they have to be for that truck. And it's important to understand that it's truck dependent. So I could have two rigs that are identical and built off the same spec, but they could be plumbed a little differently depending on when they were put on the manufacturing line. And that plumbing difference between the two is going to have an impact on how I pump my lines. Flow testing is going to allow me to figure that out.
Now, you touched on it a little bit. You touched on those internal diameters. So, the next question was going to be, is every 1 3/4 or 2.5 or 2-inch line the same in terms of flow? Obviously not, because you just mentioned, there's that internal diameter as well. But if not, beyond that, are there any other differences that people need to be aware of when they're purchasing their hose lines? Not every 1 3/4 is the same, and here's why. Is it just that internal diameter, or are there some other things that maybe it's the manufacturing process used or something like that goes into that? Andy, what are some of the other things? Why is it that not every 1 3/4 line by everybody is the same?
So
for flows,
what I'll say is, it's really important to understand when you're deciding to purchase hose or stay in a particular hose brand or model. It's important to first understand that it's not just hose that you need to evaluate. It's a hose and nozzle package. They're a package deal. So I can switch hose and let's say the internal diameter stays the same, but if it's constructed for high pressure operating pressures and I'm using a low pressure nozzle, then I'm going to have a problem at the other end. So really, I need to evaluate everything together. But one of the things that we ran into at the department that I work for, like a lot of fire departments, sometimes we just buy a hose and buy a particular brand based on price. And when we do that, we can end up with different hose brands and manufacturers and models that all say 1 3/4, but they can have different internal diameters. And then when I put them on the rig, that really means that I have different pump pressures and hose coefficients. So the department that I worked for, we had 4 different types of 1 3/4 hose within our fleet while I was there, which all had different coefficients, which all had to be pumped at different pressures. So it became really, really important to know what kind of hose that I had on the rig so I had my pump pressures correct. And one thing that really some folks don't think about is if I buy a certain hose from XYZ hose manufacturer, the flat width of that hose might be different than brand ABC, and that comes into play when I'm speccing a rig because oh no, my hose won't fit in the tray. So I know that there are some manufacturers today that are getting really, really apparatus manufacturers that are getting really specific and saying, hey, when you tell us what hose you're carrying, I need you to tell me the hose brand, the model, how many feet it's going to be in there so we can make a tray that actually will fit the hose that you're using. And you can't turn around and say, oh man, our 1 3/4 hose won't fit in the tray. Gotcha.
Bill, how about you? Anything you wanted to add about what the difference is between the different, you could have, you're calling them both 1 3/4, but there's some things different about them?
Yeah, I agree with Andy, everything he said there. And I have a couple pieces of hose here, different manufacturers, but these are both, see if I can, 1 3/4 hose, but like Andy was mentioning there, one is definitely wider than the other. Also, with the internal piece, you can see like this particular piece of hose here is smooth. And then another brand of 1 3/4 hose has all, see if I can get you can see all them grooves inside there, which creates turbulence in that water and more friction loss. So it's imperative, like Andy mentioned, we match the hose with the nozzle. We want to match the hose with the truck as well. And if we try not to mismatch any hose off of our cross lays or off the back of the truck, we usually try to buy the same hose brand so that we know when we have our pump pressures set that they're going to be accurate at the nozzle itself.
So we either bought the new truck with new hose, or we just replaced a lot of the hose, maybe all of the hose on one of our existing rigs to something new. Now that we've done that and we've made the decision, okay, now we got to go out and flow test these lines to ensure, and really what we're doing here is ultimately to keep our firefighters who are at the nozzle end of all this safe and with the appropriate with the right flow for what they're trying to do. What are some of the different ways to test the flows in these hand lines? There are there are some that are more traditional. There are some that are more, reliant on technology. Talk about some of the, Bill, I'll start with you. Talk about some of the different ways to test the flows on the hand lines.
Yeah, we test them two different ways. We'll put a flow meter in line, and that'll give us, and we make sure it's important that we calibrate that flow meter. We do it every year so that we know that it's an accurate number. And then we're going to put a pressure gauge at the nozzle, right behind the nozzle, and it tells us what that nozzle says. If it's supposed to be a 50-pound nozzle, we need to have that 50 pounds at the nozzle. If it's 75, so on and so forth. And then we try to match that flow meter with that gauge the best we can. And there's some times that you'll notice that we're flowing what it says we're supposed to flow, but the pressure gauge may be a few pounds off. So, and like I say, we just dial that in, put a firefighter on the end as well. How's it feel, and just go that way.
Andy, how about you?
Yeah. So, one really good resource for folks that are trying to maybe do this for the first time or get into doing this, I really recommend you go to Brass Tacks and Hard Facts. Their website. They have a couple episodes in their video series that actually outline how you should lay things out, the equipment that you need. And it's essentially like Bill said, right? So the episodes that you'd want to look at if you're interested in that are episodes 20, 84 through 87. They actually take a really deep dive in what you should be doing when you're flow testing your equipment. But like Bill said, the major pieces of equipment that I need is to do it most efficiently. I want a flow meter. I want pressure gauges to, determine and make sure that I have the pressure at the nozzle, like Bill said. And if you want to get really down to the nitty gritty, it's advantageous to have pressure gauges in the middle of the line, because now I can calculate friction loss per 100 foot. And then I always like to start my flow testing with a smooth bore, and I'll calibrate my flow meter with a pitot gauge just to make sure, like the first test, hey, it's calibrated with the pitot gauge, the flow meter, they're reading together. I can trust that everything else is going to go smoothly, especially if I'm using combination fog nozzles. The one thing I picked up from, what most flow meter manufacturers will say, and the biggest thing that they hit on in the Brass Tacks series is where to put the flow meter. So you have a couple options when you're doing a flow test. What I have found to be the most efficient way to do an entire pumper or to do multiple pumpers is put that flow meter going into the intake of the pumper. And now what that does is you don't have to move the flow meter to every single discharge that you are going to test, but it also allows you to make sure that you have a nice straight stream of water going into the flow meter and therefore into the pump. One of the common issues with flow meters is, especially apparatus flow meters, is they actually need a certain amount of straight pipe leading to where that flow meter registers its reading. And if there isn't a straight enough piece of pipe there, it'll cause turbulence, which will give you an inaccurate reading. So when I put the flow meter on the inlet side of the pump, preferably a 2.5-inch auxiliary inlet, and then I put 2.5-inch hose that's at least 10 feet straight, I can really rely that is going to be a true accurate measurement of the flow, as opposed to going on to a discharge. If I go right to the discharge on the pumper, I'm going to get some inaccuracy. So it's probably going to require me to put the flow meter downstream in the middle of the line. And that's one way to do it. You're going to be breaking it and reconnecting it multiple times throughout the flow test. Whereas just putting it on the intake side of the pump, you can just leave it there and it's good for the whole operation. One thing that I will say about that, and I have made this mistake in a flow test, is if you're using a 2.5-inch flow tube like what we have right here, right? This 2.5-inch flow tube, it's really important to make sure that you use 2.5-inch hose feeding it. I've made the mistake and used 3-inch hose feeding it, and the difference in that 3-inch getting neck down while it went through the flow tube caused some turbulence, and it actually was showing us that we were flowing more water than what the pitot gauge was showing at the tip. So fortunately, we corrected that because we looked at the pitot gauge and saw that, hey man, the nozzle pressure is way low than what it's supposed to be, even though the flow meter is saying that it's flowing what it's supposed to. So making sure that you do that correctly, that's a big one.
Okay, now Bill, you mentioned calibrating the flow meter that you use for this. You do it annually. Is that something you have to get a third party to do? Is that something you do in house? How does that work?
Yeah, it's a third party. We don't have the means to do a calibration. I'm sure maybe some bigger departments do, but we send it out to a third party. Same basic crews that do our hydrostatically testing and all that.
Okay.
Or back to the manufacturers, another place to send it.
Okay. I wanted to talk about elevated master streams as well. I'm thinking of maybe like platforms or a pre-piped waterway on a straight stick. Are you using the same? Bill, I'll pose this one to you first. Are you using the same the same theories here, the same procedures to test the flows at the end of those at those nozzles as well?
So what we use on our master streams is the flow meter that's built into the truck. It tells us our gallons per minute. One of the things I was going to mention later is it's not as accurate as a calibrated flow meter. And the reason we use the flow meter that's on the truck itself is because our flow meter that we have is only a 2.5-inch, like what Andy showed there. And it wouldn't keep up with what we are trying to flow.
Okay. Andy, anything on that with master streams? Anything you?
I have done on some trucks. I have done flow tests on the actual aerial device because the department wanted to know, hey, if I want to flow 1,000 gallons a minute, what do I need to pump the aerial master stream at? And while that's beneficial, it's worth doing. It's important to understand that it's a little bit harder to set specific pump discharge pressures for an aerial device because the one variable that always changes is the elevation in which I'm operating. So if I say, hey, always pump at 165, right? Well, if I'm all the way 100 foot in the air, I got to take into account the elevation and add that too. So it's important for operators to know that as well. Like Bill said, the flow meters on an aerial are not typically as accurate. I use them to get me in the ballpark. And for viewers that haven't checked out the podcast we did a couple months ago on Master Stream nozzles, this is another reason why I really like to have a smoothbore tip on my Master Streams, because between looking at a pressure gauge, looking at the flow meter, and then looking at the stream, I can say, yep, all three of these look like I have a really good stream. I'm in the ballpark for my flow. I'm happy with where I'm at. Whereas an automatic nozzle at the end, the stream is always going to look good, even if the flow is, pretty terrible. So that's one of the advantages of the smooth bores on those master streams. But the biggest thing that I like to hammer on, and if you read like an IFSTA textbook or a Jones and Bartlett textbook, they'll tell you that most elevating aerial devices have an appliance loss of about 25 pounds at 1,000 gallons a minute, which is a good rule of thumb. But it's important to recognize that's only at 1,000 gallons a minute. And a common mistake that people make is, especially when we get into elevating platforms that are capable, some flowing 15 up to 2,000 gallons a minute, right? If I only apply 25 pounds of loss for that appliance loss, I'm going to severely underpump what I need to be delivering at that tip at 2,000 gallons a minute. So it's important to remember that when I double the flow rate through anything, hose, a nozzle, appliance, a waterway, friction loss quadruples. So if we're using 25 pounds as the generic number for appliance loss at 1,000 gallons a minute, if I'm trying to flow 2,000 gallons a minute through a tower ladder or a ladder tower, right, the appliance loss just in the waterway alone is in the ballpark of 100 pounds. And I've dealt with some towers that you're looking at 120, 130 pounds of loss just in the waterway. So, in order to flow those larger volumes from an elevating platform, just understand that the pump pressure is going to be up there. It's going to be in the 200 to 230 pound range.
Okay. Now, once you put all this together, and I'll focus back on hand lines here. It seems like like the master stream could be a whole other podcast in and of itself. But getting back to the hose lines, once we set all that up and we've done, we've hooked up the flow meter, maybe we've done the PDOT gauge. How accurate is that really going to be, Andy? Like when we get to that point, and is there like a plus or minus here, or is it pretty much, if you do it right, you're dead on?
Yeah, so that's a really good question. So it's important to recognize flow meters are great, and Bill hit on it earlier. It is really important to make sure they're calibrated, and either to do it, third-party testing, or some of them you can do on your own if you know what you're doing. But it's important to recognize that the NFPA standard says that flow meters only have to be accurate to plus or minus 5%. So 5% is a pretty decent variance, plus or minus. So what I set my flow meter to typically, depending on the one that you have, you can set it to read in gallon per minute increments or 10 gallon per minute increments. I typically will do it in the 10 gallon per minute increments because that gives me a better idea. I'm in the ballpark. Do I really worry if I'm trying to get, like the example Bill gave before with a 7/8 tip, if my flow meter is reading 160 and not 161, I'm okay with that, right? I'm not gonna worry about that too much. But it's also really important to understand that, just like a pressure gauge has an area where it's most accurate and an area where it's not as accurate. And typically that's the middle of the scale. So what some of the flow meters out there will do is there's a way to calibrate it for the flow range that you most commonly use. So for example, my 2.5-inch flow meter, right, and that flow tube, I can flow and it's accurate for 500 gallons a minute. However, if I don't routinely flow 500 gallons a minute and I'm in the more like 150 to 160 gallon per minute range, right, and it's calibrated to read very accurately at 500 gallons a minute, it may not be as accurate at that low range. So it's important to say, okay, well, when I'm using this flow meter, we're really doing hand line work for it. So I want to make sure that it's calibrated really accurately for like 200 gallons a minute. That'll cover me for my 1 3/4 hand line flows, and it'll be good for my upper end of my 2.5-inch flows. And I can trust that that's pretty accurate.
Hey, Bill, how about you? Same kind of deal. You're fine with like that range, or how do you usually determine the accuracy of what you're testing?
Yeah, exactly. So with the flow meter, I'll put if it's a smooth bore, we'll use a pitot gauge, but most of the time it's some type of fog nozzle. And if we have a fog nozzle, we use that pressure gauge just to see if we're getting that right pressure at that at the nozzle itself. The flow meters on the trucks, though, I have found that they have been and sometimes up to hundreds of gallons off, by just not being, calibrated in so long. And we also had the flow meter, like what Andy showed earlier, was, 20 to 30 gallons off when it came back calibrated. We were using the same exact pressures before it left. We thought it wasn't right, so we sent it to get calibrated. It came back, and it was like 25 to 30 gallons off. So it's very calibrated.
one thing just to add, and I know we were talking about hand lines, but just one thing to add with the master streams too, right? Like we said, they're ranges. So, I've had trucks where you're pumping, the stream looks great coming out of that smoothbore nozzle. The pressure looks good on the discharge gauge, but the flow meter says, I'm only flowing 1,800 gallons a minute, right? And I want to be flowing 2,000 gallons a minute. Well, at that high range, right, plus or minus accuracy, right, I'm going to use all my context clues to say, yeah, maybe the flow meter's not saying 2,000 gallons a minute, but the stream looks like what a 2,000 GPM stream should look like. The pressure's where I know it needs to be. I'm safely saying that it's 2,000 gallons a minute. And let's be real, on a fire like that, does it really matter if you're flowing 1,800 gallons a minute or 2,000? Probably not. But same thing, even like on our straight sticks. If I'm trying to flow 500 gallons a minute and the flow meter is better calibrated for that 1,000 gallon per minute range, it might show that you're flowing a little light, or it might show that you're flowing a little high. So it's really important to use all those context clues, because flow meters on trucks, right? Every fire is different. I could be flowing 500 gallons a minute today, 1,000 tomorrow, right? It just depends. So use your context clues.
And I think that's kind of a critical point to make there, for the pump operators. In this case, do not rely on those flow meters that are on the pump panel. Rely on the math you've already done. Rely on the work that has been done to establish what those pressures need to be, and rely on that, not necessarily what that particular instrument is telling you at the pump panel, which is it's almost like it's almost like getting like a pilot to stop relying on all the computer stuff in the cockpit all the time and look at his gauges almost. So I think that's an important thing. Just to use as a reference, but do the homework before you start flowing. But speaking of the flowing, when we've been talking about hose lines, like attack lines, and we got a little bit into the master streams. But can these same principles be used at hydrants? I happen, and you guys know your response area as well. Bill, we talked about the water you're getting out of your hydrants a while back when we were talking about four-way valves. And I'm pretty familiar with the system that I have in my area. We had all the mains were either relined or replaced a number of years ago. So our hydrant system now gives us some decent water. But for other places, the condition of the mains can really impact, the flow coming out of that hydrant. You may be expecting one thing and you're going to get another. Can we apply some of these things to the hydrants as well to test their flows to ensure maybe not getting out and checking everyone in your first due, but certainly getting out and checking the ones that you would be using for some of those high hazard locations? Can we use some of these procedures there as well at the hydrant? Andy, I'm sorry.
Yeah, absolutely. You can, but I caution people because depending on how you hook the flow meter up to the hydrant, there could be turbulence coming out and you can get erroneous readings. My preferred way to flow test hydrants, you should be flow testing hydrants, or somebody should, whether it's the fire department or the water authority. But my preferred method is to actually use pitot gauges and cap gauges. And if I prefer the main capacity test, which is essentially what we're going to do is we're going to take two fire hydrants that are on the same main. We're going to designate one as the flow hydrant, one as the test hydrant. At the test hydrant, we put a cap gauge on it. We turn the hydrant on, and we're going to measure the static pressure. At the flow hydrant, we're going to take the caps off. We're going to open the hydrant. We're going to let water flow out of it. And then we're going to take our pitot gauge and measure what the flow pressure of that stream coming out of the hydrant is. All right. And at the same time, we're going to take a look at the residual pressure on that hydrant that we are designating as the test hydrant. So we take all that information, we plug it into a formula called the Hayes and Williams formula. And what that's going to do is it's going to calculate and tell us what the flow capacity of that main feeding those two hydrants is at a residual pressure of 20 psi, right? That's the more scientific, mathematical, and reliable way to actually flow test your hydrants. You can use a flow meter in these instances if you don't want to use the pitot gauge to measure what the flow coming out of the flow hydrant is. But really what you need to do to actually get an idea of what the main can give you is actually perform that main capacity test.
Bill, how about you? Anything you've done in your department? I know you said that you've got tremendous water, but maybe on the volunteer side, no, that was no hydrants on the volunteer side, right?
Yeah, we have like 30 hydrants and 64 square miles on the volunteer side, but so we use a lot of tankers there. But yeah, what Andy mentioned there is exactly what is what we do at both departments. Using the pitot gauge, we will not use a flow meter on the hydrant itself. We do the cap and static and residual pressures.
Okay. We just touched on very, very briefly there the rural environment, and the rural environment is going to have different static water sources. There are many bends and hills. Certainly the operator on who's doing the drafting. How do you test for the variety of exposures in the rural environment to ensure that what's going to the lead pumper is enough to provide the handline flows that you've tested for? Bill, I'll start with you on that one.
So with in the rural setting, we watch the vacuum. Like if I'm drafting, I'm going to watch that vacuum gauge, and as it gets closer to that 30, we're going to just add that extra intake, whether it be another piece of hard suction, and just flow to the apparatus that we're filling up. Usually, it's a filling station. When we're doing our drafting in the Fayetteville area, we are going to draft at the filling station so that we can pump to the apparatus ahead. We're watching that gauge. We're not using a flow meter at those instances because it's an actual emergency incident. We are just going to, like I say, watch that vacuum and discharge pressures, and then add more intakes if we need it.
Is there anything you can do before the emergency to test this out and see, or is it really just you're not going to know until the emergency?
No, we go out to any site that we have. We've gone out to every site that we would use in our jurisdiction to test these, to make sure that we're getting that. Our goal is to get 1,000 gallons a minute to these tankers as they're coming for filling.
Andy, how about you? Anything? Any tips for the rural environment?
Yeah. So the concepts with regards to flow testing a rural engine are they're the same for an urban engine on the attack line side, right? We're going to do the same thing, same layout, just like we talked about for a rural engine as we would with an urban engine. The difference tends to be right, and really we could make this argument in the urban setting too. I know some fire departments will flow test their large diameter supply line, and you can do that. To me, in my experience, it's really not as important, just because, if I use coefficients from the IFSTA textbook for 4-inch O's, 0.2, and for 5-inch 0.08, right? Yes, there have been some advances in large diameter hose technology, and maybe those coefficients are a little smaller than they are, but it's not the same change like we see in the attack hose. So for me, in the rural or even in a relay pumping situation in an urban city, whatever it is, I am still going to rely on calculating the pump pressure based on, rules of thumb, friction loss operations. So I like to dumb it down and make it really simple. Okay. So when I'm dealing with a relay operation, whether that's a pumper drafting out of a dump tank, pumping to the attack engine, or, pumping a hydrant, pumping to a relay, whatever it is, I always start my math at 500 gallons a minute, because I know that, no matter what, unless my attack engine has some wild plumbing configuration on the tank to pump line, if they're operating off their booster tank, they're not going to be able to flow more than 500 gallons a minute, because that's what the NFPA 1900 standard says that they have to be able to flow. So I'm going to start my math for 500. And, if I'm dealing with 4-inch hose, I know that that's 5 pounds per 100 foot. If I'm dealing with 5-inch hose, it's really 2 pounds per 100 foot, right? And then I'll just add some intake pressure on top of that. And then the next number I remember is 1,000 gallons a minute. So if 500 isn't working, I'm going to do my math for 1,000. So if I'm in 4-inch hose, I know it's 20 pounds per 100 foot. And if it's 5-inch hose, it's 8 pounds. I just round up to 10 pounds per 100 foot. And again, just add some intake pressure to the next rig. So, when it comes to large diameter discharges and pumping between rigs, I really rely on, actually calculating the friction loss based on, coefficients that are pretty close, and doing it in the field that way.
So something to add there, in the rule setting here, one of the things we do, Andy mentioned the 500 gallons a minute when we're pumping from one truck to another. And any truck that we have that we know we're going to be pumping from one to another, we've always spec'd out to have an extra intake or tank to pump valve.
Yeah.
So we get that extra gallons per minute from the tank, where we're able to flow 1,000 gallons a minute plus from one apparatus to another by using its booster tank because of those added tank to pump valves.
Now, once we've got it all together and we've tested the lines, we know what the proper pump discharge pressures for each line needs to be. What are some of the ways that you all have communicated that to your operators? Obviously, there are some things that we go through during pump ops classes and things like that, but it's that proverbial 2:30 a.m. in the morning call where your mind just goes blank. So I'll start with you on this one, Bill. What are some of the ways that both of your departments communicate the pump discharge information that your pump operators need? Is it just a tick on the gauge, or is there something laminated somewhere? What do you guys do?
So anytime we get a new apparatus, I take and I flow meter, and flow each discharge off of that apparatus. And I create a pump book for that. So inside that pump book is going to have page by page on every discharge. Along with that discharge, if you had to add extra lines to it, what would the pump pressure be then? So that it kind of dumbs it down for the operators that they don't have to do the math on an emergency scene. They can get that book out, and it tells them exactly what pressure they need to have on that particular discharge based on how much hose is off there and what nozzle's on there. So, like I say, every apparatus we have at both my departments has this pump book, and the operators know when they're getting cleared where to find that pump book and how it's worked.
Andy, how about you? How have you communicated this in your experience?
Yeah, I live and die by a pump chart. I love me a pump chart. So, like Bill said, on our rigs in the city that I worked for, we flow tested all of them, and then we came up with individual pump charts for each rig. And on those trucks, they were laminated and put in the operator's compartment or something like that. But I tell people, like, those pump charts, I tried to make as simple as possible. So it was 3 columns, right? The discharge, the flow out of the nozzle, and the pump pressure that you need for that pre-connect. And then, we had another chart underneath that had more complex hose layouts, like gated Y scenarios and stuff, extended lines like Bill had talked about. But we laminated those and actually mounted them in the operator's compartment. That is, and I know some people love roll-up doors. One of the reasons that I like the lap door and the reverse hinge on the operator's compartment is I could open that door and I had all my pump information just facing me at the pump panel, right? So it was just a really nice thing. What I know that some departments do, there are companies out there that you can actually, send your pump chart to, and they will laser engrave, your pump chart on a piece of tin, and then you can mount that onto your pump panel with double-sided tape, and that way it's right there on the pump panel, and you can look at it at 2:00 in the morning, and it's good to go.
To wrap up this discussion before we get to a question from our mailbag, we've talked about a number of different things. Andy, you mentioned putting the flow meter on the 2.5-inch intake connected to a 2.5-inch line. Bill, you've mentioned another couple of things, but are there any other tricks that the two of you have developed over time for testing hand lines and nozzles to make sure that that your pump operators are pumping the right pressure to get the right flow? Bill, I'll start with you.
Well, I don't know if it's a trick or not, but when we buy hose, we bring multiple manufacturers in and test their hose, and we put a firefighter on there that's maybe not as experienced as others, and let them tell us how that feels. When we're flowing those right pressures and those the right gallons per minute, we want the firefighter to be happy with what the line feels like. If they're not, then we move on and we try to find something else.
Okay, Andy, how about you?
Yeah.
Any other trick?
This is I don't know if it's a trick, but it's something that has resonated with me. In one of my old fire hydraulic books, it's actually called Fire Service Hydraulics. It's a real deep dive in all things hydraulics. And one of the things that the author talks about is, and he mentions that whenever there's a bend in hose, there's loss. I'm not talking about a kink. I'm just talking about a bend in a hose line and an S, right? And the author says that on average, each bend adds about 6% more friction loss to that hose layout, right? So the more bends you have in a hose layout, right, the more friction there's going to be. And I'm not saying that you have to calculate that on a fire ground. I wouldn't expect you to do that. That's not realistic. But when I flow test, what I try and tell people to do is I want to stretch my hand lines out and flake them out like they would be at a fire. I don't want to, I've seen, and I've done mistakenly, I've stretched a pre-connect off the rig and pulled all 200 foot in a straight line, flow tested it. And then what's going to end up happening is my numbers are actually going to be too low because there's not enough resistance for the bends to account for all those bends. So just to make sure you're getting the most accurate number for what you're going to be doing in the field, deploy it like you would on a fire. Right? It's going to have some bends, right? I'm not talking kinks, but it's going to have some bends, and then test it that way. So that way you get more of an accurate number for what things are going to look like in the real world. And your numbers probably aren't going to be what you calculated it out if you did pen and paper and the coefficient method and all that.
All right, cool. Well, thank you very much, both of you, for talking about this in this episode. I can't emphasize enough, really just how important it is to do this, especially if for some reason you've got two different manufacturers of the same size hose theoretically on your truck. Knowing what you need to do to get the proper pressure to get the proper GPM to the personnel at the end of that line is critical. So making sure that you do all this is very important. I did have, though, a question that we received. This is from Ed Levy. He is from Michigan. And he did, we always ask if you have any questions at all, let us know. We'll get them answered for you. And so here's one that I'll throw out to the two of you, and then, you guys can both discuss, the theory behind all this. But, this person asked, Ed asked, are there fire hydrants on large mains that can flow 3,000 GPM, assuming two 4.5-inch ports are both being used? So I'll just throw it out to the two of you, and then you guys can argue amongst yourselves about whether or not that's possible or not, or whether or not you've experienced it. Take it away, guys.
Yeah. So the easy answer is yes. So I've dealt with hydrants on really strong mains that are traditional fire hydrants with a single 4.5-inch steamer port and two 2.5-inch side ports, and I have gotten 3,000 in one instance and 3,500 off of a single hydrant in another. Now, we can argue whether or not that is the most efficient. What is probably more efficient on those larger mains is to have one pumper pump that hydrant and then maybe have another engine go to a hydrant that's still on the same main and deliver the other remaining portion of that supply to the fire scene. But to answer the question, yes, it is possible. Now, when we get into those scenarios, the big thing to remember and understand is the limiting factor is not going to be volume in those instances. A lot of times it's going to be the horsepower of the truck's motor, right? You're probably going to run out of apparatus motor to move that volume of water before you run out of water. And in fact, we actually, we installed one here at our fire academy in Tennessee. We have what we call a double steamer hydrant. So it has two 4.5-inch outlets on the steamer. And when we hook two engines to it, and then those two engines hook intake to intake and do a dual pumping operation, we have been able to flow 4,000 gallons a minute off that single hydrant with a residual pressure at the hydrant of 20 PSI. So not doing any damage to the system, not dropping it below the 20 PSI, anything like that. But you can get some really, really, really big flows off that single hydrant if you connect to it the right way. The key is just knowing whether the main can support it.
Bill?
Yeah, I agree with Andy. If we're looking to flow 3,000 gallons of water, we're definitely using more than one apparatus. At least in our world, there's industrial, systems out there where the pumpers will pump 10,000 gallons a minute, but I don't have that experience. And yet, to answer the question, no, yes, we've gotten over 3,000 gallons out of a hydrant doing what Andy mentioned, using all outlets.
All right, guys. Well, thank you very much. And if you have any questions that you would like Andy or Bill to answer, please let me know. You can email me at chris.mcloone@clarionevents.com. Before I let you both go, I just wanted to remind everyone that both Bill and Andy will be at FDIC. They are each teaching a class at FDIC. You can get more information on those classes by going to FDIC.com. You'll have to navigate to the conference area and the classroom sessions, and then you can search by their last names. In fact, I also have heard recently that the two of you will be hopefully guests on the FDIC live podcast that we'll be doing from there. So everybody, please keep an eye out for that as well. We'll have a schedule for that hopefully soon. So again, my thanks to both Bill and Andy for taking some time out and continuing our water delivery topic here. If you have any topics, again, please let me know. chris.mcloone@clarionevents.com. If you would like to look at any of our other podcasts that we've done so far, go to fireapparatusmagazine.com/podcast, and they're all available for you there. Of course, they're also available on most of the podcast platforms and also on our YouTube channel. So take a look there as well, especially if we've had any props that we've shown. So again, Bill, Andy, thank you very much today for joining me. Again, this has been Chris Mc Loone with Bill Adkins and Andy Soccodato, Fire Apparatus and Emergency Equipment. Have a good one and stay safe. Thanks again, guys.